All right, welcome everyone to the SDA Skills kickoff. What we'll be doing today is we'll actually be spending about 50-60 minutes just walking through how do you prepare for interviews, how would you build a roadmap, and then how can you track progress. What we'll also do as a part of this is that we have like a few programs that we have in flight, and if there are any other questions or anything, we can handle that as well. So before we just jump right in, a quick word about SDA Skills. Some of you might be new. So SDA Skills, so we essentially set SDA Skills up pretty much around early 2010. It's been through multiple name changes and incarnations, but over the last 8+ years, almost 9 years, what we've been doing is focusing on improving their technical skills for engineers and essentially overall community, and simplify the technical interview process that actually is happening. So that's what we're trying to do. And it's a typo on the screen, but we are also a registered 501c3 nonprofit as of 2017. So for the last couple of years, we've been in that mode. So jumping in, one of the things to realize is a lot of you may be at the different career stages, and one of the key things to note is that interviewing or technical interviewing actually applies to a large variety of roles. So it actually applies to, and they're quite different for different roles, right? So most commonly what we are focusing on here in SDA Skills is on the dev side of the roles, or dev roles, which is basically, you'll see titles such as software development engineer, SDE, you see engineer, developer, and roles such as those. But we also have other roles which are like, quality assurance engineer or software development engineer in test, and these are like test specific roles. We also have DevOps roles where essentially the focus is a bunch of development, and then there's quite a bit of element of like operations, which is around environment management, build operations, and things like that. So and then we also have program management, where you're actually in the process of delivering software in large teams. And of course, you also have engineering management and people management roles as well. So one of the things to recognize here is that as you are going through different roles, you'll see that there's an element of, since these are all like, a lot of these are tech roles, you will see a bunch of questions that are being asked, which are primarily focused on what have you done, what have you delivered, and things like those. So we are so as a part of this conversation, we are primarily targeting the dev roles, but you will see a lot of overlap in all of these things. And in some scenarios, quite a few of you are actually in a fungible state, where you are debating whether you need to pick up a DevOps role, or should you pick up a program management role, or should you pick up a dev role, and some of you have a little bit of people management, so you may want to think about engineering manager role. So it's a little nebulous in terms of what you want to pick up. So that's something for you to learn and assess to see where you actually would be better fit. So but let's understand what are the competencies that are typically and what we're looking at is for most of these roles, what you're looking at is first and foremost is that you need to understand the requirements or the needs of your customer that you're essentially working with, or the company that you're working with, the organization that you're a part of, or your team. So are you able to understand, articulate, and are you able to solve the problems on behalf of your customer, on behalf of your company? That is first and foremost. And in an interview process, typically companies are actually trying to assess and identify if you are if you're actually have you successfully demonstrated that in the past, and can you demonstrate that again for us in the future. The other one, of course, is the ability to deliver tangible business value. I mean, at the end of the day, companies are here to make money, and they make money when you actually deliver products and value. So the whole idea is that, have you been successful in delivering significant business value is something that will be often asked. And can you deliver with business value is essentially the other question that they're trying to get to. And of course, we are operating as a team in almost all scenarios. So the goal is to make sure that you're a team player, which means that you're actually able to work with a variety of engineers. You have empathy towards your peer engineers. You are actually providing, you're very thoughtful in terms of how you're providing feedback to your peers, whether it is actually people who have less experience than you or more experience than you, and so on. And then, of course, communication skills are actually valued significantly. And when I say communication, I kind of mean full duplex. It's not just about your ability to articulate, but it's also your ability to listen to what people are saying, understand, perceive, and then react to that, and then essentially provide follow-ups based on that. And last but not the least, like being predictable. Like people would love to actually work with engineers or managers who are very clear at setting expectations, what to expect from them, and essentially to meet or beat those expectations. Now, why are we actually walking through these personal skills? It's very hard to prepare for these, and unfortunately, the SDA Skills prep that we do does not cover these topics at all, or doesn't cover these topics in great degree of detail. So this is something that is extremely important. This is one of the areas where otherwise great engineers actually fail because they don't do a good job of like being able to articulate what they have done, being able to build stories, having like a compelling resume, and to be able to articulate the contents of their resume in a way that actually describes how they have been and how they're able to understand the needs of the customer, how they have delivered value on behalf of the customer, and things like that. So that's what the personal skills element of it is sort of all about. Now, so this is super important. Unfortunately, we will not be covering any of this in most of our SDA skill program, curriculum, classes, and whatnot, because these are very specific and very personal, and it's actually super hard to be able to, like, this would be like a one-on-one kind of a session, and that's how it actually would end up working. All right, just moving on. The more important aspect of it is essentially functional skills, and these are very specific functional skills that are there for the programming interviews. And if you add QA or program management or engineering management, you have other core skills that will be added to it. So essentially, from the top, we are looking at a few basic things. You need to know how to code. You need to know how to solve problems. You should have the ability to deal with ambiguity, and you need to understand how large-scale systems work and how the system components interact with each other. And then there are a bunch of like functional skills that are absolutely essential for specific jobs, such as SQL, writing the ability to write SQL queries, big data, or things like that. So why are these skills important? Is this is what you will be using day in and day out in your jobs. So you should be able to, like in a typical sense, more often than not, you will be given an ambiguous problem to start with and say, here is a customer problem you're trying to solve. And it will be your responsibility as an engineer to walk in and then ask clarifying questions, learn more about the problem space, brainstorm ideas with your peers, and then come up with what would be a good problem space or problem set that you're trying to solve. And that's essentially the ambiguity management element. Once that is done, you're actually now into the realm of solving the problem. Now that you know the problem, let's actually go figure out what are the existing solutions that we have in place, and how do we solve for those problems, and how do we actually come up with a meaningful way of delivering a solution that will work for the given problem. Now, once that aspect of it is, now you know the problem, you need to make sure that the design of whatever problem, the solution that you've had is extensible. Is one of the concepts that you would see is that we want to make we want to fail fast, in the sense that you want to have the ability to identify designs or problem solutions that don't work, and you want to identify that quickly. You don't want to waste days, hours, like days, weeks, or months trying to figure out whether the solution to the problem actually will work or will not work. So you want to fail fast. And the other thing you want to do is that you also want to make progress without actually being bogged down by lack of data. Like if you don't know certain aspects of it, it is absolutely imperative that you're able to build an open-ended, loose design that can potentially be adapted as you learn more and more. Like having strong couplings or painting yourself in a corner with some strong assumptions are hallmarks of poor design. Now, once you're done with all of this, of course, the bread and butter for engineering is to deliver this, and how you deliver this is through coding. Now, that's sort of the uber functional skill methodology that we have. Now, what I wanted to do was take us forward and see how we can build a roadmap with this. So what I'll do is I'll just wait here to ask for any questions before I move on. So far, is there any challenges, concerns about the role and the competencies? Go ahead, Gaurav. Unfortunately, I can't hear you, Gaurav. You may want to type your question. Okay, so no, I don't have. So anybody with any questions? Are we so far? Any questions? Going once, going twice. All right. So let me carry on with the roadmap as such. All right. So here is like a broad set of items that I generally track when I'm actually looking at someone, and someone tells me like, hey, I'm ready to interview at company X or company Y. Then I ask them like, how are you with your programming fluency? And when I say programming fluency, pick a language of your choice. It doesn't matter whether it is Java, C, C++, Ruby, Python, Perl. It actually doesn't matter what programming language you pick. I generally recommend picking one of the popular ones so that the interviewers are familiar with it as well. But you need to be able to write code without actually having to think too much about it. Standard tests for this would be that if I ask you to write a code, write code which says, fine, just like, given a list of numbers, like print alternate numbers or print all the even numbers, or, write a program that computes a Fibonacci sequence or something like that. You shouldn't even have to think. All you're doing is writing a while loop or a for loop, or you're actually using a bunch of if conditions. You have how to check specific scenarios, how to do if then else, and things like that. So that's basic programming fluency. Now, many places where people actually fail here is that you should know how the edge cases work for a for loop. You should know how the language idioms work, very specific, like assignments, assigning arrays, how do you define an array, how do you actually set up a hash map, or whatever the data structures that you're trying to use, how do you do all of those. You should be able to figure that out in your specific language of choice. By and large, what I've seen is most interviewers actually don't care about the syntax errors, because you're actually writing the code on a whiteboard. So there is no expectation that you'll do it right. But on the other hand, more of interviews are now being conducted on a laptop in like a shared coding session or something, where if you miss some things, or if you miss functionality, if you miss syntax, then that actually shows up as well. In general, from an interviewer's perspective, I think anything that you can actually find out in a quick Google search, it's not worth testing. But at the same time, I don't want my candidates to be searching for what is the syntax for a for loop in C++. I mean, that just seems like at some point you should know certain things. Don't just expect Google to help you all the way, right? So that's all the programming fluency. Now, the next set of data structures and algorithms I keep asking is around how comfortable are you with like arrays, strings, linked lists, stacks, queues. These are fundamental primitive data structures. They are very simple extensions on top of this simple integer and other primitives. So this is just one level removed from the primitive data structures. Now, specifically for arrays, you're looking at single dimension arrays, double dimension arrays, Linked list is essentially you have even both flavors, the singly linked list, doubly linked list, the ability to actually map a queue and a stack using an array or using a linked list, and questions around those. In general, I have not seen interview questions like specifically focus on arrays or linked lists or stacks or queues, but most interview questions will require you to have some fundamental knowledge of these things. Like you should know when to use a stack, you should know when to use a queue, and things like that. Gaurav, do you have something to add? Okay, I just put him on mute. Sorry about that. All right. So carrying on. So that is basic data structures, right? And again, the goal here would be that I'm expecting most of the folks who are looking at an engineering position, SDE1, SDE2, to be extremely fluent and comfortable with basic data structures and algorithms. The algorithms around arrays would be around sorting algorithms. Linked lists have reversing a linked list and merging two linked lists and things like that. Stacks and queues are essentially how do you deep copy stack, deep copy queue, and then there are like a few other algorithms that go with it. So that's what I'm expecting, what I expect people to know. On the intermediate data structures, which is a little more advanced than the basic ones, but there's a little bit more to it as well, is you need to understand what trees are, sets are, how to use a set, and then what's a dictionary or a map. And understand where they are used, understand how they are constructed, how do you add an element to these things, how do you remove an element from that, and this also includes other auxiliary concepts such as a tree typically has multiple variants, right? So you have like a binary tree, you have a binary search tree, and you have algorithms which are specifically that are essentially how do you find an element in a binary search tree, how do you make sure that a tree is a binary search tree or not, how do you mirror a tree, and how do you compute like the least common ancestor and things like that. So these are all like standard sets of questions. Again, these questions are actually are fairly fundamental. I do expect people to know these questions, the answers to these questions. In many cases, I have seen these questions being asked as is in interviews. So as in find the least common ancestor of a given tree, or they're asked in some variants of this, saying like write like implement a hash map or something like that. Or these are actually fundamental questions these are data structures that will be used in other questions. So you may be given some sort of like an implementation where you're asked to find a largest find the top 10 elements in an infinite stream of data, or find the median of an infinite stream. You would end up using a heap in that particular case. A heap is nothing but a type of a tree data structure. That's a priority queue. Now, so for intermediate data structures and algorithms, again, they may be asked as is, or they may essentially form a part of a bigger interview question. Following on, the next one essentially is advanced data structures, or slightly more advanced in terms of data structures and algorithms, is tries and graphs. Now, if you're depending on where you are in your career stage, and depending upon how you actually are, how or what kind of companies you're working on, sometimes they don't ask this. Like tries are reasonably very oddly specific data structures. It's a prefix tree. It is used in very specific scenarios. Sometimes your questions may have that, sometimes it may not. So if you're just starting out and you're looking at programming fluency and basic data structures, I would just stop at intermediate algo, DS and algo, and I would probably go towards graphs if I have to, but I may not because again, graphs are fairly commonly asked, at least the common algorithms that we're talking about, which is depth first search, breadth first search. And we're also talking about like even in trees you also have in-order traversal, pre-order traversal, and all right. So it's sometimes worth it to actually follow on. It's sometimes worth actually spending some time on the graph specifically because that's more common. The tries are fairly obscure. Now let's look at the next topic that I have in my list is essentially dynamic programming. Now, dynamic programming is a tad bit, it's an oddball, because one of the things with dynamic programming is that it's a reasonably complicated series of algorithms. Actually, I will cover engineering manager roles in a bit. Let me just go through the focus areas and I'll do that. So the one thing with dynamic programming is that if you really understand how dynamic programming questions, how the problems are actually structured, and if you're able to understand the construct of these questions, and if you're able to apply the dynamic programming algorithms, then pretty much a large swath of dynamic programming based questions become super simple. And one of the advantages or the beauties of dynamic programming is the problem solving is complicated, but then the translating to code of this problem or the solved problem is actually fairly simple. And it becomes a double-edged sword. If you go to an interview and they ask you a dynamic programming question and you're not able to answer it, you will fail. But if you're able to answer the question in the sense that you're able to come up with a solution, you will be able to translate the code, and it doesn't take a whole lot of time for the code. So that is essentially the thing with dynamic programming, and it is definitely a topic that I would expect people to focus on, and it is definitely a topic that, depending on which companies you're targeting, especially the top tier companies are doing this a lot more often. They ask a lot more of these questions, and again, it's also a fad. I've seen it come up sometimes. I've seen it go away for like a few months in months when I don't hear anything about any dynamic programming, and then suddenly I see a lot of that being asked, and I think it's probably got to do with like different interviewers just entering the arena in these companies, and it just happens to be favorite for some and not so for others. So that's something to think about. Just moving on to the other topics that we have. Next one is OO design, which is essentially object-oriented design, object-oriented concepts, design patterns. This is something that is usually asked for slightly more senior engineers. And when I say slightly more senior engineers, it's actually anywhere from like 5-6 engineers of years of experience onwards. The whole concept here being you need to have been exposed to some of these things as a part of your work. Unfortunately, some of us are actually working on hardware design and embedded systems and things like that, so we may not get exposed to OO design. I still recommend learning what these concepts are because they get asked. Companies are trying to find ways to get around this. So what they do is they try to ask questions which are more around logical and maintainable systems as opposed to object-oriented design. So they're trying to work around parts of it. Then the next topic is essentially data, the databases, and I mean big data is here to stay. No matter how or where you're working, you will be dealing with reasonable sizes of data. May not be in petabytes and more, but it may probably be in like megabytes, gigabytes, and terabytes. So having millions of rows, maybe hundreds of thousands of rows. So having an effective system that actually manages, tracks the data, and is more effective is something that we'll end up almost always covering as a part of system design questions. But databases in and of themselves are something that people need to focus on as well. System design is again well known. Search for it, you'll find it. Just looking at building systems and components where you're actually just breaking things into components, where scale is a big deal. You need to know how to actually optimize by caching, figure out how multi-threading works, figure out how concurrency is handled using figuring out using locks and semaphores and things like that. So that's that side of the story. Again, system design is something that is usually not asked for someone with like less than 3 years of experience, but depending on where you are in your career stage, your entire interview might just be system design or flavors of system design. The last one I have here is essentially auxiliary prep. So the ones that you've done in the top are all like fundamental concepts and core system things that you're learning. When I say auxiliary prep, I'm actually specifically looking at things that you would need to do to essentially learn to organize your own personal journey. and make sure that you're able to answer questions specifically in the domains that is being asked. So more commonly, system design, for example, if we give me an example of a complicated system you've designed, tell me what was so complicated about it, why did you choose what you chose, and what was the advantage, who did you get, what were the trade-offs, and things like that. Now, if for someone who's actually worked for 10 years, 15 years, you may be tempted to pick a system that's large, but unfortunately a little further back in your career, and you may not remember all the aspects of it. So there is absolutely a need to go back and revisit whatever you have done. I mean, I don't remember what I did 6 months ago unless I prep. So I'm expecting that's what is the case with most of us. So please make sure that you actually read through your resume, go through each part of your resume and see where you've actually solved complicated problems, where have you solved people problems. So if you look at the previous aspect where I talked about the personal skills, about communication, about earning trust with your engineers, about being a team player and things like that, you need to have examples from projects that you've worked with and that you've listed in your resume. Auxiliary prep is not a very big deal in the sense that it's not something that you want to spend a lot of time on, but it is something that is super critical and you don't want to avoid it. That it will be a huge gap. And one of the things I've seen is especially for junior engineers, I see this as a challenge because people with no experience or minimal experience sometimes feel that I don't have any experience, so I don't have anything else to prep for, and I'm only going to prepare for all these situational questions and things like that, and that becomes hard. One of the things that I actually recommend is that what I want people to do is start thinking about in terms of rubric, right? Around where are you for each of these items that we talked about, like programming fluency, basic data structure. Where do you stand? You could be as granular as you want, and you could track yourself in terms of your basic DS algo, or you could be going down to arrays, strings, linked lists, tags. I mean, you could go as detailed as you want. But essentially, what I'm looking at in terms of rubric is either you start with like none, which is essentially I have no idea, or you say you have like basic knowledge, which means you are like you're aware of the concepts, but you may or may not be able to apply it in problem solving. If you're intermediate, that means you're comfortable with it, you can apply the skills. And then when you're advanced, which is essentially you can identify the need for these things, and then you should be able to apply. For example, do you know when something is a tree problem? Or do you know when something is a graph problem? Or do you know when something is a dynamic programming problem? That essentially gets you to the advanced state. Now, and the next one, of course, is expert, which is essentially saying can extend the knowledge. This one is usually around either you can teach others or you can kind of draw inferences from different types of questions and problems, and you should be able to identify patterns in questions and also in these answers. Typically, I am expecting folks to be in somewhere between the intermediate to advanced stage for most of the basic concepts, and I'm expecting folks to be in like maybe in the intermediate for the advanced topics, like such as dynamic programming or something, and then that should be enough. How would you know where you are? You probably have to test yourself. Hey, Gaurav, I think I'm just hearing a lot of noise from your side and I'm not able to hear you at all. I think you have a very bad connection. One thing you can do is just chat and then I can answer your questions if you need to. I'm going to put you on mute because I just hear noise from your side. All right, moving on, right? So this is a rubric that I follow, and what happens is you just have to take each of the items in the functional area and then say where you are, and then identify where you want to be, and then you can map out like how do I go from none in intermediate data structures to basic to intermediate to advanced. How do I actually go up in my skill level on each of these metrics? That's what I would like to get to. Okay. Any questions on the functional areas and rubrics?
Hey, I got a question.
Go ahead. Who's this?
You mentioned about ambiguity management. Like I couldn't get that with respect to the other slide. How do you link ambiguity management with other functional areas?
Just who's this? All right, let me actually. I thought I'll refer you by name, but that's okay. So yeah, so what I was. Can you repeat your name again, please?
Ram.
Okay. Hey, Ram. So ambiguity management is more around. So typically, you are looking at figuring out how to solve. You have to first understand the problem, right? So for ambiguity actually comes in each of these areas, each of these data structures, each of these questions. So typically ambiguity becomes a personal skill and not a functional skill. Ability to deal with ambiguity is essentially, I want you to be able to, given a problem statement, you should be able to break it down into its core and understand what is relevant to what does the customer ask, what does the customer need, what part of the problem is relevant and what part of the problem is actually less relevant, and which one do you want to prioritize to solve for. Asking and a typical interview response pattern is you spend the time to understand what the problem is, and you ask clarifying questions, and you actually make a few assumptions and validate those assumptions. A very common question would be one of the questions that I've seen for package delivery or something like that would be to say that we have a mailman, like a UPS truck driver, and we have a bunch of packages and we have a bunch of addresses. Now what we want to do is we want to figure out which package should be given to which mailman so that it's more efficient. Now this problem has no information at all. You don't know what efficient means, you don't know what the limitations look like, you don't know what the packages are, or how big are they, and what are the complexities, and are we talking about hundreds of packages and thousands of mailmen, what is the limitations of what you're trying to do, right? So spending the first 3 to 5 minutes in your interview focusing on this is essentially a learned skill, and that skill would be what the dealing with ambiguity, actually that's where it comes in from. That's how you demonstrate in an interview. In the real world, that's exactly what happens as you are encountering any problem. Like the way you ask clarifying questions to make sure that you and the person who's actually communicating the problem statement to you are on the same page. That essentially gets you the ability to deal with ambiguity, which is essentially managing ambiguity as well. In some cases, you don't have to get all the pieces of information up front, right? Some amount of ambiguity is okay. You can defer it for later as long as your system design is open and flexible. Does that make sense?
Got it. Thanks.
Any other questions?
Hi. Can you go to the next slide? This is Ranga.
Sure, Ranga. Go ahead.
Yeah. So can you elaborate on the expert can extend the knowledge? What it means, and then with some examples.
Yeah, absolutely. Thank you. Essentially, let me repeat what advanced is first, and then we can get to expert as a delta of advanced, right? So someone who can actually call themselves an advanced in a given say data structure would essentially be someone who can identify when this data structure can be applied, or what kind of problems can this data structure solve. And the focus there would be essentially saying, given like an ambiguous problem or an arbitrary set of data. Like if I were to tell you that I'm trying to find a way to track like the birth dates and the death dates of like all the people ever born in the world, right? Then you have to start thinking about what kind of data structure would I actually store that in. You could store that in a list, you could store that in a linked list, or a queue, or a stack, or an array, or a tree, or a graph, or something. But then the challenge is it's all about what are you going to use it for. And if I were to say that I'm trying to identify how many people actually lived in the same time period, like given 2 or 3 people, I would like you to tell me if they are contemporaries, as in they were alive at the same time. Right? So if I need that, then you need to start thinking about what kind of data structure you need to use. So then if you have advanced skills in those specific data structures, then you should be able to map, you should be able to figure out that this problem requires these kinds of data structures. Now as an expert, what I'm expecting is that you should be able to expert goes in a few directions. One is I'm looking at people actually, you know enough that you can actually teach others, that you can actually coach and explain the data structure, not just why or what it is, but also how it is even constructed internally and how does that work. And you have like insights within the data structure that essentially helps you map or combine data structures as well. Like for example, people understand heaps, right? Heap is a data structure. Now, if you're familiar with heaps, that's great. It's a tree-like data structure. It's fine. But as an expert, you should be able to see the similarities of a tournament tree and a heap. Not something very common. A tournament tree is essentially, if you look at like the Wimbledon tennis or something, you will see like A played with B and C played with D and E played with F or something. That forms the base level. And then one of them wins, and then the next level A plays with D, and then E plays with G, or so on, right? And then you write that, and eventually there's one eventual winner. A heap is actually a tournament tree which is just space optimized. You may want to figure out how that actually works, and that I expect expert to make that inferences. In general, I don't want folks to actually spend time to go from being an advanced to an expert. It doesn't really help a whole lot, because purely from a time spent standpoint, right? Like if the goal of your data structures preparation and everything else is actually to clear job interviews and to be able to use these data structures at work, then I think advanced is probably the most you need to get to. But if you want to actually be spending a little bit more time being fascinated by these data structures and want to be in a position where you can intuitively solve problems and also like invent data structures which are combinations of different data structures, then you might need to be then you'll essentially be in the expert field. So
yeah,
I don't know if that answered your question, Ranga, but
got it. Thank you.
A great session so far. I have a question. This is Kiran.
Hey, Kiran.
Hey, so I think these typical interviews, they go into the spiral mode. They try to check like with you, okay, you know these data structures and all. That's all fine, right? Basic knowledge. And then when it kind of comes to the time complexity, I mean, it's more than just understanding the data structures in deep. There's usually a trick to solve a problem. So most of the interviews I have attended so far, it's mind-boggling. Whether you know it or not. So there's no way you can solve that in that particular time. But it doesn't matter how many years of experience you have. So it boils down to that 15-20 minutes, whether you know that or not. You can't solve that I feel that the previous Microsoft questions are much better, puzzles and all that. There is no need to code, but now it's much worse than that actually. So you have to you have to be an elite code expert, to be frank. So
I think it's a fair ask, but let me throw a little bit of a spin on that. In a good interview, the fact that you know the question already is actually is not helpful, in the sense that ideally most folks want you to not know the question, and they want you to derive the question or the answer to the question based on the fundamental data structure knowledge. Unfortunately, questions are very hard to create, so people just cheat and then copy questions off of lead code. I mean, I don't know whether people copy off of lead code or lead code copies off of what companies are doing, but essentially it's the same set of questions that keep being repeated over and over again. The one thing that I've seen good interviewers do is that they actually have a variance in the interview question. So if you have seen like a type of question being asked where you need to use a graph and then you need to do like some kind of a depth first search, the question actually changes a little bit. The interviewer changes the question a little bit so that the mechanics of the process remains the same, but the question has a unique perspective that you can only answer if you understand the answer. It's not about knowing it, as in knowing the question or solving the question once already, but it's actually about actually learning the fundamentals of the data structure, which is where if you're just in the basic to intermediate range, you will not be as successful as being in the advanced for those specific data structures. So I think
my question is this, right? Usually, I mean, I have like 15 years of experience. I go into specialized field, for example, data science or something. So the problem is all these companies have a wall, right? So they ask these questions as a first screening which is like kind of stupid in my reasoning, because you lose out a lot of skilled people, but they have this fixed process even for data scientists and all that. So I'm getting there, but it's just it feels like wasted time. You have to prepare for this. This is never easy. Getting through the data structures and all, it takes so much time, right? It takes almost like 3 to 6 months easily to get to that interview clearing experience. But it's like a moving train, right? So the more number of problems you keep solving, they keep adding more, and it's never ending a problem. But the problem is this, right? I don't code this stuff on my daily basis, so I don't see the value in the sense like if they're testing the knowledge, I feel like age-old MSET or IIT multiple choice questions are better, more breadth than here. You have one depth question, and if you don't know it, you're basically done. So
it is unfortunate, and unfortunately, I don't define the rules of the game. I just am here to play the rules of the game within the rules.
I know. Yeah, so I'm just giving my.
No, totally. I think your perspective is very valid, and sometimes the entry criteria is actually mismatched from what the job actually needs, and that is a challenge. Like I'm trying to be as broad based as I can, and this is more of multiple companies are actually looking for a bunch of functional skills, a bunch of core skills, a bunch of personal skills, and we are trying to make sure that you possess those skills, or you have enough of those skills so that you can be coached into the role, so that you can come in and be successful. And that's the whole purpose of the interview process. Now, many companies have taken almost like a shortcut, right? Which is they're using even machine learning and predictive learning to figure out what to ask, and it's just that, I would just ask you a question saying, choose a number between 1 and 100, and if you pick a number, I'll just say pass or fail, because in my experience, people who have picked prime numbers have been successful and others are not. I mean, this is just idiotic, but it is what it is. And sometimes they try to obfuscate the purpose of it so that people don't game the system. Otherwise, everybody will start picking prime numbers, and then that test is useless now. So it becomes a constant cat and mouse. Unfortunately, there's not much there. So anyway, this is where we are. Any questions so far? So that I can talk through. There's one more question that was actually asked, which was around what roles of SDM. I just wanted to spend some time talking about that. Any questions? All right. So one question that is on the chat, which I just saw right now, is saying typical for tier 1 companies to hire 15-20 years experience folks as senior engineers. So this is very maybe this is Amazon specific, because Amazon has SDE1, SDE2, SDE3. Some companies have more gradations. Like I think Microsoft has a lot more levels as you go through the process. What I have seen is generally someone who's between 0 to 4 or 5 years of experience tend to be junior engineers, or they are just essentially considered as freshers, or people who are just learning the skill and required to be supervised as a part of their day-to-day operations. And generally they get things done, but they're not independent when it comes to solving customer problems or working on projects. And then somewhere between almost 2 to 3 years of experience all the way up to 8, 9, or maybe 10 years of experience is where your software engineers are. These are the bread and butter. Like at Amazon, we call them SDE2s. Microsoft has a few ranges. Google has, I think, different levels and whatnot. But these folks are essentially the workhorse of the engineering organization. They do a bunch of the problem solving. They do a bunch of delivery. And they are the ones who are actually growing the SDE1s into senior engineers and so on. Now, the next level is essentially an SDE3, and that I have seen people with as few as 7, 8 years of experience be SDE3s, and I have seen people with 20, 25 years of experience also be SDE3s. So, and that SDE3 I think has an equivalent level in Google. I think is L5. Microsoft has a different level. And then on it becomes principal, senior principal, distinguished engineer, and whatnot. So, and at that point of time, the number of years actually does not matter. It's what you have done and what you're delivering and what your skill set looks like. So most companies, I think this SDE3 or the senior software developer tends to be like the career stage, as in you could potentially retire as an SDE3, spend like 30, 40 years of your engineering career, and then like, when you leave, you're probably an SDE3 at that point of time. So that's my take on the specific experience levels, but it's fairly subjective, so I don't know if I can answer any more than that. Okay, so going back to Achyut's question is what does an SDM engineering, what is an SDM role or an engineering manager role, and what are the expected focus areas? So the SDM focus areas are actually so going back. This is back to the engineering roles that we talked about, right? So one of the key things is an engineering manager is typically, and depending on which different companies, the roles are different. The engineering manager is essentially the organizational leader. So a typical engineering manager, which is like pure play engineering manager, would be managing a bunch of engineers, and the focus would be you would know how to hire engineers. You would know how to manage the careers of your engineers, how to grow them from like an SDE1 to an SDE2, SDE2 and SDE3, and so on. You know how to do that, and that people management aspect of it is. So that's one aspect of it. The second aspect of engineering manager is around technology management. You own the roadmap, the vision, the charter for your team, and you're able to carve out like a space that is unique to you. So typically in many organizations that I have seen, an engineering manager with about 8 to 10 people is like frontline engineering manager who owns a small organization, is the one who's actually has a strong goal of, I'm in the business of, I own this product or the service, and I'm in the business of making this product or service better for my consumers. Here is my engineering roadmap, and here are the things that features that I will deliver at various points of time, and my engineers will help me deliver all of that. So that's the engineering manager's role. So which means that in interviews you will be tested for your people management. Have you hired people? Have you grown people? And sometimes it's actually then one of the most common questions that's also asked is like, have you fired people? Have you actually let people go? Do you have turnaround stories of where poor performers have been made into better performers? What did you do? And then you also have other stories where you're talking about like how do you mentor and coach and make your higher performers even better engineers. One of the weird interview tactic that I saw was essentially something to the effect of, I know you know how to handle great engineers. I know you know how to handle terrible engineers. What do you do for the middle? That is your body of your engineering, right? You only have in a team of 10, you probably have 2 people who are performing extremely well, and you have 1 person who's probably performing poorly, like bell curve of sorts. What about the other 7? They are the ones who are actually producing bulk of your output. So how do you manage them? What do you do? How do you motivate them? And that sometimes takes people by storm. And a typical answer, typical negative answer is essentially something to the effect of like, I do nothing, the team takes care of itself, is not what you want. Like you need to have your own specific vision around what your role in this particular activity is. And then the third pillar of an engineering management is also about being able to represent your team upstream. So you are the one who's representing and committing for your team's deliverables in front of directors, VPs, SVPs, and so on. So being able to present and defend your roadmap, being able to secure funding depending on what type of organization you are. Some of these organizations are budget based, so which means that you'll have to make a case and then get a budget and things like that. So different organizations have different roles, but typically an engineering manager focuses on all of these things. Now most of the things that we talked about in terms of interview questions, data structures, algorithms are typically not something that is tested for software dev managers, because this is at a too low level, and it's for like leads, which is somewhat like a engineering lead manager, which is like a step between a people management and a software engineering lead. So you could be somewhere in between. Again, a lot of these things actually depend largely on your career stage as well, right? So it's very hard to provide specific guidance without knowing your specific role. Let me just do one more question before I jump into the roadmap aspect of it. Is Kishore is asking, does SDE3 role also ask like algorithmic, or is it only design questions? It's actually a very company specific setup. I know that Amazon, Google, Facebook, they actually ask coding questions, which are algorithmic for senior engineer roles and even for principal engineer roles. There are a few companies where there is like a architect role, where the role is essentially designing and building systems and dealing with scale, and generally they wouldn't be focusing on writing code and writing the last mile, right? So for those roles you don't have algorithmic interviews as much. So that kind of, I think it works differently for different organizations, unfortunately. All right, so let's actually switch over. I think I wanted to talk about like how do you build a roadmap, right? We talked about the, so let's do the best practices part of it, right? So here's what I generally recommend. Like, I mean, it's been ages since we probably have been used to studying in school. Some of you are probably recent college graduates, so you may actually have some more insights into this, like how to study and how to be more productive. But what I found was that everybody is an individual. They have their own native thought process. Your biases are different. So what I would recommend is, like, generally when you're starting your interview preparation, just go grab a fresh notebook, and then what you do is that from the beginning of the notebook, you start like write down the questions and the solution that you're getting, like whether you're doing lead code, whether you're actually doing cracking the coding interview questions, or whether you're solving your own personal things or whatnot. Just go pick a question from the front of the notebook, write down the question, write down the solution. Also make an annotation of how much time did you take. Just write down when did you start and when did you finish. So that gives you like a way of measuring time and keeping track of it, because you want to know how to solve it faster. One thing I do mention is that a typical interview is about like a good interview is about an hour long. If you take away all the goods in the beginning, right, whether it is like have all the pleasantries and good mornings and everything else, you're left with about 50 minutes, and take away any questions for me and everything else, about 45 minutes. The interviewer actually takes about 5 to 10 minutes to explain the question, and then there's clarifications and whatnot. So you're actually looking at about 30 minutes of sheer coding time that you may get, or sheer problem solving time. So given a problem that's posed to you, you should be able to get to different parts. You should be able to get to the problem solving quickly, and then you should be able to understand, identify the data structure, and you should be able to jump into the coding aspect of it. You want to leave like 10-15 minutes for coding so that you can actually mix write meaningful code. Unless of course the dynamic programming, in which case the coding is very small. It's probably like 5 minutes of coding is more than enough. But then write it down, and then now think back and maybe you look up the answer as well, right? Once you've looked at this, now you go back and say, why did it take so much time? Why did it take you 45 minutes to come up with this answer? And what if somebody could give you a hint? Like, what if somebody told you, have you considered a tree for this, or have you considered a graph for this? Or what if somebody told you that you should actually consider bottom up versus top down? I mean, or things like that, right? Those hints would actually help you solve them faster. I would generally recommend, like, flipping the notebook over, start writing the hints from the back side of the notebook. Okay, and keep doing this. And then at some point of time, all you have to do is revise your hints, because then you would know. And then as long as you're able to replay those hints, you'll actually get better and better at solving. So this is like a technique that has actually worked pretty well for quite a lot of folks who've been preparing in the Seattle tech interview groups. But that's something that we found to be fairly effective for us. And again, do remember that the quantity and quality is always a conundrum. I know people who actually attack, like, I have solved 500 lead code questions, 300 lead code questions, and they're still struggling because every new lead code question that they see, they're not able to solve it. Whereas I've seen people who have actually solved like 50 lead code questions, and they're actually in a much better position of being able to answer the questions and being able to adopt whatever they have learned into new solutions. So that's like a technique that I see people use, and I've seen that to be fairly useful. Any questions on the prep, on the practice, on the best practice? Right. So moving on. So another concept that I've actually been floating around, and we've actually had some limited success with it, is that you want to these preparations are actually in waves. Like if you have only one day to prepare, like you have an interview tomorrow, what do you want to do today, right? So you want to revise your hints, and you want to revise questions, and you want to revise concepts, but you have only limited time. So you've got about 4 to 5 hours of time on the day before the interview, right? So you've got about 8 areas that we talked about in the focus areas. Maybe spend about 30 minutes each, or maybe like 40 in some, 20 in some, but spend about that, right? And then you spend about 1 hour in your auxiliary prep. Your auxiliary prep is just like, reading through your resume, making sure that you have like good recall of everything that you've written, and then you have like stories around what you want to tell the interviewer and things like that. Learn about the job, understand what the job description says. If you know the hiring manager, if you know the interviewers, look them up on LinkedIn, see what their experience has been. It all helps you connect with that. So that would be the day prep that will happen the day before. What if you had like 1 week to go? Like your interview is next week. What I would typically do is pick 2 focus areas each day.
होल्ड पर है, लाइन पर बने रहें या कुछ देर बाद कोशिश करें. Your call is on hold. Please stay online or call back.
Sorry about that. So yeah, so if you're on, what do you do if you're on like a day, like 5 days, or you have like a week? Then what I do is I just pick 2 focus areas per day, spend about 4 days on the 8 focus areas that I have, and then just like on the 9th or the 5th day, just repeat the 1 day prep. Spend more on the topics that you think you need more help, spend less on the topics that you think you're comfortable with, but again, that's what works. And then the third thing I have is essentially a 14-day prep, where you can probably do like 1 day, 1 focus area per day, and then just have a rest day in between focus areas, and then just have auxiliary prep. And then for the last 5 days, just repeat the 5-day prep story. And then if you have 6 months, then what I would do is I'd actually go through this thing in waves. Like I would do this like 8 days cycle multiple times, or the 9-day cycle with an auxiliary prep, right? Now, there's no point in spending too much time with auxiliary prep. The 8-day prep cycle makes sense. So think about doing that. That's a lot more valuable. Somebody was talking about like, should I spend 6 months preparing? And what I've seen is it takes about 6 months for people to go from a beginner to intermediate in everything, to essentially go from intermediate to advanced, right? In all the topics, it takes people about 6 months to get through the topic. And when I say 6 months, it's 6 months of like you have your day job, and you're actually working on a daily basis, like a couple of hours here and there, and then you probably spend like a solid day in the weekend preparing. So with that, you should be able to get to a reasonable degree of confidence and strength in about 6 months, and that you can accelerate it by spending more time. But at some point of time, it's the amount of time you spend has got diminishing returns, so doesn't really help a whole lot. So any questions? So yeah, good question, Babu. Saying when you're interviewing in Java, Java is evolving pretty rapidly, and you don't know all the features with the latest release. How do you deal with it? Most of the times, what happens is that the interviewer is actually also not aware of most of these latest things. So when that happens, it's use what you know and carry on with the interview. So as an interviewer, like I am actually struggling I don't understand the new parallel streams and things like that well. I haven't used them in interviews, and I will really struggle if a candidate actually comes to my interviews and insists on solving using parallel streams. So when that happens, my usual strategy is like, hey, explain parallel streams to me. Tell me how this works, and then we have a conversation on how those streams work, and then we can solve the problem based on that. But bottom line here is that we are looking at solving interview questions, and we are actually looking at your ability to translate algorithm into code, and not really the edge cases and nitty-gritties of Java. But that being said, if you know them, use it to your advantage. Many years ago when Java 5 was introduced, Java started with the for each syntax, where you actually would say for like int I colon array, and then it'll just work, which was so much different from getting an iterator and then doing a hash next and things like that. So it was like a lot easier and convenient to actually do that in an interview, to just do that. It's pretty simple. So anyway, I hope that answers your question. Any other question before I move on to? I think I have one more slide. That's all. Right. This is essentially the last slide. We have a bunch of programs that are currently in flight. One program is essentially I call it Programming Interviews Easy. What we will do is in the same meetup, probably using the same Hangout session, whatnot, we will be solving about maybe 2, maybe 4 interview questions in an online fashion. I'll share the questions up front. The first one is happening next week, and the one after that is every 4 weeks after that. And that's one meetup. Everybody is welcome. If you RSVP, it's just easier. Then when I post the questions, you will know. For people in Seattle or East Side, in like Redmond and Kirkland, other areas, we do have in-person meetups every week. Feel free to join us. The meetups are oversubscribed, so please add yourself to the wait list and show up anyways. So far, we have not had a full meetup in the room where like people sign up and they don't show up at times. So we have enough spots, like 10-15 spots are almost always there. So far, we've not had a scenario where we had to turn away people. So I would just encourage you to add yourself to the waitlist and show up even if the meetup stays full. That's for the in-person meetups. And then we are also solving lead code questions. We do 3 questions each week, and they are on the Slack. So if you're not on Slack, please join. It is sdaskills.com/Slack, and once you go there, it will actually send you a link to. It will take you to the sign up process, and once you're in, please join the hash lead code practice channel. Will by default be in one channel. You can always join other channels as required, and then just go ahead. We have multiple channels. There's one channel for the San Francisco meetups as well. We don't have an in-person meetup in SFO. Unfortunately, for various reasons, we don't have someone who can actually lead the sessions yet. We're trying to identify a few people who can do that. But that being said, if there are people in San Francisco who want to meet up on a regular basis, please feel free to reach out to me, ping me on Slack. What I can do is I can actually enable you to set up meetings in the meetup forum so that people can find us and things like that. And then you can go ahead and book the rooms, set up your own topics, and then sit together and practice interview questions. I mean, that's there's no substitute to that. So that's all I had. Questions? We've got about 20 more minutes in this session left. So any more questions? It doesn't have to be on this topic. It can also be on interview preparation in general. And if you cannot speak or if you're on mute, you can always type the question in the chat. So yeah, the first one is essentially for the the Pi meetings are already set up in the SF Skillets. You should be able to go right now and RSVP to those. Babu, the presentation slides have already been shared. You can actually look at the comments in the meetup, and you should be able to see the slides there. Let me see if I can paste it here as well. Yeah. So the PDF is here. More questions? Yes, actually the in-person sessions are recorded, so you can go to YouTube and look for SDA Skills, and that you will see all the past meetups that we have. Let me just
Hello?
put the link to that. Hi, I can hear you. Just give me 1 minute. Let me just finish the answer to this question, and then. So for YouTube, we actually record the sessions. Pretty much, we've been religiously recording every session. I have been uploading the sessions as well. One of the feedback elements that we got was instead of recording like a 3-hour session and uploading it, it doesn't make sense to, because there's a lot of white noise and dead noise. So we wanted to chop it up into meaningful questions and upload. And that has actually given us like a backlog of about 10 meetups at this point of time. So we are heavily backlogged, but I think there's like 60 videos or so in the YouTube channel. So you should be able to, I think there is enough videos for you to
Hello?
for you to watch. Yes, go ahead, please.
Just want to ask, what's the expectation? What is the difference between expectation, but like between what is expected from 4 to 5 year experience guy, or between like 8 to 9 year experience guy? Like from SD1 versus SD2 in Amazon.
In most companies, I mean, the role is different, right? SD1s are expected to be essentially like they're expected to deliver on what has been assigned to them. And given they don't really go beyond, like they own like a component or like a small module, and then they can deliver on that. And SDE2 is generally expected to possess a slightly more wider based knowledge. And because of that, what I see more often than not is that the SDE2 interviews are a lot more like they focus on a little bit of design, a little bit of ownership, and a little bit more of try to understand what people are.
I'm from.
Go ahead.
I'm from embedded domain, working embedded C. Like, how much do I know about the scale caching? Because I guess most of the backend guys, like we are working with web services using REST and all. Most of those guys like are involved in such type of things. Should I also like know about these concepts?
So the bigger question
I
for
will
you would be,
by the way.
The question for you would be: are you looking to move away from the embedded design, embedded systems, into the kind of like the web services world? These are different worlds, right? What makes you an expert in the embedded design, embedded systems world is different from what kind of skills you need to be successful in a like machine learning space or big data or web services, right? So you may want to think about where you want to take your career, and then and then see if you want to retool. That's a good thing. The challenge, you will run into issues with in system design, and what we have seen is a lot of people who are trying to make a career shift, especially for people who are into either like kernel development or hardware engineering, things like that. When they try to come into like Amazon like environment or a Google like environment, it becomes a lot more. They struggle with the design question primarily. We've kind of compensated for not having OO, but OO is fine. If you don't know object-oriented, it's fine as long as you're able to do modules and compartmentalized stuff. But that's what it is. Does that make sense? So I think this is a skill that you will have to acquire more than anything else.
Okay. Thanks a lot.
Okay.
Yes.
All right. So one more question that was on the chat is how do you answer design questions when you have not practically worked on them? Actually, that is almost the expectation. So what happens is that in most cases I've seen, people ask two types of design questions. One is essentially a design question where you need to explain what you have worked on and tell me more about how you have solved a complicated problem and tell me what the system design looked like and things like that. And there you're expected to know everything because it's your product, right? But on the other hand, the other type of interview question is where they give you like a hypothetical problem statement, and then they would say, here is what it is. Like, imagine I have this one thing where I'm trying to solve for this, and here is a problem that I have, and tell me how to deal with it. The expectation is that you don't know what that problem space is. You are expected to essentially walk down the clarification, requirement clarification, and things like that. I would definitely recommend there is like I think 2 or 3 sessions that we have recorded on the YouTube specifically on system design, and there's one on over design. where what we do is that we walk through like the steps of a problem solving exercise, and we'd say, what's the very first thing you need to do? You need to actually go make sure that you understand the requirements of the system, and then you do other things. Like, it's too premature to jump in the scale conversation right off the bat. You want to understand the problem first and then slowly move into the scale much afterwards. So I would encourage watching the video, and you can skip the discussion part of it if you're not interested in the discussion as such, but the top and the process is actually very illuminating. System design may or may not be asked for product managers, but it's definitely asked for program managers. The reason why system design is asked for program managers is because at least if you look at Amazon or if you look at Google or other large companies, the program managers are actually usually working with multiple teams, and the footprint that your system actually covers is fairly large across multiple systems. So you need to have the ability to conceptualize a given system into abstract terms, and you should be able to understand what design patterns are going between the systems. How do you actually build systems in an abstract way? How do you have them decoupled? What is the cardinality between the data sets that you're looking at? Is it a one-to-one relationship, one-to-many relationship? And what is the timing of the event, sequence diagrams, and things like that? So the expectation would be that the program managers are able to understand that and are able to shepherd the discussion based on that. And the same thing applies for engineering managers as well, because that's the thing that your team is working on. So there is definitely system design aspect that is covered for both program managers and for engineering managers. And I've seen both questions that I talked about, right? Where explain a system that you have designed and explain this new system that you have no idea what it is about. I've seen both. Okay. Any more questions?
Okay. Yeah, one more question I have. What's the best source? Like, there are so many, like Geeks for Geeks, Lead Code, HackerRank, like, or any other strategy or any other method you want to suggest, because that's the only source I can find to solve the algorithm problems and with dynamic programming and all.
Lead Code is good for questions. It's actually a good resource.
Okay.
Geeks for Geeks is actually pretty good for again for concepts, and I think I like the way the concepts are explained in Geeks for Geeks. That's actually good. For system design in general, I think there is one of the thing is this, right? A lot of the material is actually free on the internet. Like, if you just Google the right things, you'll always find it, right? A lot of people have written blogs. I mean, the YouTube channel that we have has a lot of questions. There's like Tushar is another one where he actually walks through a lot of these concepts. So there's a lot of good things there. But one of the things I've seen is the Grokking the Coding interview is Grokking the System Design interview. I think it's like a $80 design training thing that is there in educative.io. You can search for Grokking the System Design. You'll find that. That is it's reasonably expensive, but it's also a good resource for the price point. I mean, it is like you are not paying for the content, but you're paying for somebody's actually taken time to put that together, so you're paying for that. And it's a very effective use of your time. Would you rather spend 2 hours searching for the same information or not, would be a question, right? So I think I would strongly recommend that. They had a preview copy at some point in time. I saw that then, and since then I have seen that they've increased more things in the topic. I like the way they have covered that in pretty simplistic terms. So that's actually good. Anyone who's actually bought that has actually had good things to say about it as well.
Okay.
Next question is Shweta is asking questions saying, is it good to switch to SDM or engineering management role within 5 years of software development experience and then having 6 years of gap? And is there also a way to switch? I didn't quite understand the second part of the question, Shweta, but
I'm a software engineer, and then I have 6 years of gap. So now, after you explaining about the software SDM roles, which mainly includes the people management, I tend to like have a closeness to that or want to switch on that. So is there any is it a good way to do that, or is it good that I have to go into the software developer and then I can switch to that role? Or is there any way that I can do the engineering management role?
Got it. So the challenge that you will run into is essentially, unless you are a people manager, you will not be offered a people manager role. I mean, it's almost like a catch-22, right? In order for somebody to actually hire you as a dev manager, they expect you to have played a dev manager role elsewhere. Then, like, where does the experience come from, and how do you do that? So normally, what I have seen, a typical transition path is people actually start their careers as engineers, and then essentially they transition to software dev manager in a couple of years, because in order for you to be successful, you need to know the people, and you need to know the product, and you need to understand essentially the space or the domain that you're actually in. If you're an engineer in the same domain, then you already know the domain, you already know the product. The people is only new thing, and then you can always have people like mentors and coaches who can guide you through the people management side of the story. So most commonly, I've seen people join as engineers in specific companies, switch to manager, be an effective manager for multiple years, and then transition as managers to different organizations. Now, being a people manager is a very personal choice. I know people who have actually tried people management, not like it, go back. Being a people manager is actually a lot less empowering than what you may imagine. Being an engineer, you get a lot more, empowerment. You can do a lot of things on your own, and your randomizations are minimal. Whereas being a people manager, you are actually responsible for the whole team and the delivery of the whole team, and oftentimes you may not have a lot of say in terms of your personal choice. Like as a people manager, like simple things, right? Like which floor of the building do you want to sit in? You may actually have to pick based on what your engineers decide. You may not have a say of saying, I want to sit on the 5th floor or the 6th floor or something. Same thing goes for tools, technology, choices, and a lot of other aspects of it. It's an empowering role. It has a lot of other advantages, but sometimes I see people who prefer being an engineer because it's a lot more exciting. It's a lot more like you have a sense of accomplishment, which is a lot more wider. I personally switched to a people manager after about 6 years of experience. 6-7 years of experience is what I had as an engineer when I switched to a step role to a people manager, managing about 3 to 4 people, and with about 10 years of experience is when I formally switched with about a large engineering team of 8 to 10 people.
Thank you.
Right. Any other questions? All right. So what I will do is essentially, so the video will be, hopefully I should get the recording of the video in a couple of hours or so. I will be uploading. Yeah, actually, can you go on? All right, I've put him on mute, so hopefully the feedback loop terminates. So unmuted you. Achut, you're back online. Go ahead. No, Achut, you may want to type your question. Yes, actually, that is a fantastic question. So one of the things, Kishore's question was, would you refer people for interviews after preparation? So I actually have different levels of qualities of service. So one of the most basic one that I have, which I offer to everyone, is essentially I have a pretty wide network. So the best way to actually bypass all of these things is essentially to you can use LinkedIn, look me up, look at people that are connected to me, connect with me first, but then you can look at people who are connected to me, and you'll more likely than not find somebody in the target company that you want, and I'll gladly make introduction, and this introduction would be just as an acquaintance, like, hey, here is Kishore from my extended network. He's interested in joining a company. Do you mind, spending some time with him? And that's something that I do all the time. I make a lot of these connections. No guarantees that they will respond, because obviously at some point of time I may be sending somebody to you saying, hey Kishore, here is like John, he's interested in your company, and you may choose to ignore my message, which is fine. The second thing is that people who are actually actively participating in the SDA Skills sessions, people who have actually come to the meetups, people who are participating online, and they're actually working on certain things on this, or people who are actually teaching and helping spread the knowledge. What I do is I actually take an active interest in trying to make sure that that you are that I'm able to refer you, and I actually endorse your position as well. So essentially, and this is specifically like at Amazon, at Microsoft, at Google. I'm connected with recruiters. I'm connected with engineering managers. So I actually would say, hey, here is Kishore. He is like super strong. I've seen his code. I like it. You have an opportunity for him. He really wants to work in your team. Go ahead. And this would be like people that I know personally, I know fairly well, and more often than not, you will get an interview after this sort of an endorsement. So yes, I do that as well, and it is essentially entirely based. It's just one more avenue for you to look at. All right. For SDET roles, is basic level of data structure and algorithm sufficient? Unfortunately, it depends on the company, and it's actually a pretty negative answer. So the negative answer is essentially because companies like Microsoft, Amazon are actually looking at SDETs on par with SDEs. In fact, I think Microsoft got rid of SDET as a role, and they converted all the SDETs to SDEs now. Amazon still has SDET roles, and we expect the technical problem-solving skill and the algorithm skills to be on par. So an SDET is essentially an SDE with test skills. So, and being an SDET, getting hired as an SDET is actually harder than getting hired as an SDE at Amazon because of the other things required. So the bar is pretty high for an SDET. But there are companies where a QA engineer who's actually dealing with scripting and testing, a little bit of more programming, they actually, QA would be treated as someone with just manual testing, and SDET would be someone who does automated testing. And in those companies, I'm assuming the bar will be a little different, or the expectation will be different. But at Amazon, at Microsoft, and I believe at other places, the bar is not a whole lot different. The expectation is still as high. All right, I have time for one more question, so let me do that as well. So I mentioned that grown as an engineer, 11 years to engineering manager in embedded space of 5 years, Android side, now looking for transition. Different domain and space. Any suggestions? I think the one space that I'm super fascinated about is the Internet of Things and the voice. I think Alexa has actually taken the world by storm, and Google Home has also done the same thing. And I also see Siri and Cortana coming in, but not really as much. But there's a lot of I see a lot of future in the sort of like, you know, there's something to be said about this voice-based interaction. I like that, and I've been pretty interested in working on that side of the story. So it's something for you to think about if that's something that suits your fancy. Big data is another one, because extracting intelligence out of this large volume of data that we already have is super fascinating. And the third thing that you might want to think about is essentially computer vision. It's come a long way from where it has been. Especially if you have like Android experience or iOS experience, you may want to think about can I actually interpret the images that's coming from the camera and have like augmented reality, virtual reality, and things like that. There's a lot of other elements there. So these are like spaces which I am interested in personally, and you may even see me jump ships specifically so that I can work on these technologies, but nothing at the moment. There is not much. So that's actually that's all the time that we have. I'm going to go just one more minute over to quickly just summarize. Thank you all for actually taking the time to join the session. I will actually upload the video in the YouTube channel. So if you have not subscribed to the YouTube channel, please go ahead and hit subscribe. That will notify you when a new video is uploaded. We typically tend to upload a video every week, but we've kind of been backlogged a few, so you should see some come by. Please join the Slack channel as well. That's one of our most active vehicles for communication. So please feel free to join the Slack channel and make sure that you're actually participating in the lead code, in the Pi sessions that we have, and anything else that you have. If you have any questions or any specific like asks or any questions, feel free to ping me on Slack. I am reasonably responsive. I do chat every now and then. Unfortunately, I do have a day job, so which actually takes a significant bit of my time. So I may not be able to answer your questions right away, or I may not be as responsive. Please don't give up this problem. All right? That's all I had. Thank you, everyone. I will stay on for another 5-10 minutes if you have more questions.